Hello student, good morning. I am Dr.A.J. Kumar Sinha, Professor of Chemistry. Today I am going to discuss alcohol, phenols and ethers. This is the new chapter. I have finished haloalkane and haloarine. Now new chapter is alcohol, phenols and ethers. That is the 11th chapter. What is alcohol, what is phenols and ether? Just in a brief, you can understand why we are studying alcohols, phenols and ethers. Alcohol, phenols and ethers are the basic compounds for the formation of detergents, antiseptic and fragrance respectively. What is actually main use? I have told you. Again I am telling you, alcohols, phenols and ethers are the basic compounds for the formation of detergents, antiseptics and fragrances respectively. You know that substitution of one or more hydrogen atom or atoms from a hydrocarbon by another atom or a group of atoms results in the formation of entirely new compounds having altogether different properties and applications. Alcohols and phenols are formed when a hydrogen atom in a hydrocarbon, aliphatic and aromatic respectively, is replaced by OH group. These atomic here, first before going ahead, I want to repeat it that alcohol and phenols are formed when a hydrogen atom in a hydrocarbons, aliphatic and aromatic is replaced by OH group. These classes of compounds find wide applications in industry as well as in day-to-day life. For example, you might have noticed that ordinary spirit used for polishing wooden furniture is cheaply a compound containing hydroxyl group, ethanol. For the spirit we use for polishing time, ordinary spirit we are using. What is that spirit? Then ordinary spirit used for polishing wooden furniture is chiefly a compound containing hydroxyl group and compound name is ethanol. The sugar we eat, the cotton used for fabrics, the papers we use for writing are all made up of compounds containing OH group. Again you listen. The sugar we eat, the cotton used for fabrics, the paper we use for writing are all made up of compounds containing OH groups. Just think of life without paper. No notebooks, books, newspapers, currency notes, checks, certificates, etc. This is the importance of alcohol or OH group. Correct? Without OH group or alcohol, phenol, ethers, I am talking about that. Just think of life without paper. no notebook, no notebooks, books, newspapers, currency notes, checks, certificates, etc. The magazine carrying beautiful photographs and interesting stories would disappear from our life. It would have been really a different world. Then now you can understand this importance of alcohols. Now further, an alcohol contains one or more hydroxyl group or groups. An alcohol contains one or more hydroxyl group or groups directly attached to carbon atom or atoms of an aliphatic system. Aliphatic system example which this OH can attach, that is the methane. Suppose in methane one is gone and its place OH has come. Then methyl alcohol is the best example. This is the methyl alcohol. Then an alcohol contains one or more hydroxyl groups directly attached to carbon atom or atoms of an aliphatic system. Example is methyl alcohol. While a phenol, what is a phenol? Phenol contains OH group or groups directly attached to carbon atom or atoms of an aromatic system. Aromatic system. Example of phenol is C6H5OH. C6H5OH is called phenol. The substitution of a hydrogen atom in a hydrocarbon by an alkoxy or aryl oxy group. Alkoxy, alk means here alkane. Alkoxy or aryl oxy group. Alkoxy means RO, R and oxygen. R is, when R is attached to O, means oxygen, then RO is called alkoxy. And when this arene AR or benzene, you can tell, when benzene is attached to oxygen, then what will happen? It's another class of compounds known as ethers. Ether. Okay. Then after the phenol means benzene, and with benzene OH group is attached. When with benzene means carbon of the phenol or benzene, when OH group is attached, one is gone, other place OH came, then or substituted, then that is called phenol. But what is for ether? Then for ether I am telling you, the substitution of a hydrogen atom. Everywhere you have seen H is substituted with OH in case of alcohol, in case of phenol. But here, the case of ether, you understand, the substitution of a hydrogen atom in a hydrocarbon. From the hydrocarbon, one hydrogen going to be substituted by an alkoxy means RO, or aryl oxy group means ARO. It's another class of compounds known as ethers. For example, CH3OCH3. Then here CH3 is the methyl group. From that, just to understand, from the methane, one hydrogen gone. Now OCH3 group attached. OCH3, alkoxy. Then now it formed CH3OCH3 because in the place of H, OCH3 joined. Then now it formed CH3OCH3. That is called dimethyl ether. This is the ether group with one oxygen. Both sides it has a 2 valency. Then both sides one methyl group will be there it is attached with methyl group, right side and left side. Then that O, open valency 2, that is the ether group, O, and 2 valence is opened. Then now here both valency is occupied by methyl, hence it is called dimethyl ether. And also you can say other compounds, ethers, other compounds also, suppose now here both are methyl. Now it is possible that one may be methyl, other may be ethyl. Then it will be ethyl methyl ether. Sometimes suppose both methyl group is attached, then it will be called diethyl ether. Correct? And same way that with methyl group, with oxygen, suppose one side methyl group is there, other side aryl group is there. Aryl means phenyl group. Correct? Then all possibilities are there. According to IUPAC system, I will tell you IUPAC system, but before that I want to tell you more about the these things, phenol, not phenol, ether. Substituting the hydrogen atom of hydroxyl group of an alcohol by a phenol by an alkyl or aryl group, means we can ether we can get. How we will get different, you can say, ether? Then substituting the hydrogen atom of hydroxyl group of an alcohol alcohols or phenols by an alkyl or aryl group. Okay. Then this I told you, you might have seen ethers as compounds formed by substituting the hydrogen atom of hydroxyl group of an alcohol by alcohols or phenols by an alkyl or aryl group. Alcohol is there, OH is there. Now H can be replaced by not only in alcohol, in phenol also H can be replaced by an alkyl or aryl group. Okay, then different types of ethers will be formed. Now here we will discuss in details alcohols, phenols and ethers. Classification, first I will tell you classification. The classification of compounds, making their study systematic and hence simpler. For that purpose, classification is required. The classification of compounds makes their study systematic and hence simpler. Therefore, let us first learn how are alcohols, phenols and ethers classified. Okay. Then now I am telling you classification. Like mono, di, tri or polyhydric compounds. Polyhydric compounds. Mono, polyhydric compounds may be mono, di, tri or poly. These are classification. Mono means 1, di means 2, tri means 3 and poly means more than 3. That is called polyhydric compounds. Hydric, it is related to OH. Okay. Alcohols and phenols. Alcohols and phenols may be classified as mono, di, tri or polyhydric compounds depending on whether they contain 1, 2 or 3 or many hydroxyl groups respectively in their structure. As for example, ethyl alcohol C2H5OH. Only one OH is there. Correct? C2H5OH, ethyl alcohol. Then this is the mono. Now CH2OH, again CH2OH. Means ethylene. In ethylene, from the each carbon, in that two carbons are there, CH3, CH3. Now from each carbon, one hydrogen replaced. From each carbon, one hydrogen replaced and OH came. Then it is what? When this things, glycol, you might have heard the name, ethylene glycol. Ethylene glycol. Then C, after transfer of, means just after the substitution of H with OH, in both carbon, one hydrogen gone, and now suppose OH came on each carbon. Then this is called ethylene glycol. Ethylene glycol. Here two OH is there. Then this is the example of dye. Dye. Okay. Dye alcohol, you can tell. CH2OH, again CH2OH. And both C is attached with single bond. Then this is example of dye alcohol. Two OH group is attached. Similarly, now suppose propane is there. Propane. And in propane 3 carbon is there. Then all three are attached. Carbons are attached. First and last have CH3, CH3. In the middle, CH2. Correct? Now suppose from each carbon, one hydrogen gone, and on its place OH came. 3 OH came. 3H gone, 3 OH came. It attached to the 3 carbon. Then now it is a trihydric alcohol. Trihydric. And it is known as glycerol. You might have heard the name glycerol. It is a trihydric alcohol. And ethylene glycol, that is a dihydric alcohol. Correct? You should remember. Example of dihydric alcohol is ethylene glycol. 2 carbon are there in ethylene. And here in propane, 3 hydrogen gone and 3 OH came. Yet example of trihydric alcohol. Correct? Propanol also you can tell. 1, 2, 3 propanol you can tell. This is the trihydric alcohol. Correct? This is the aliphatic. These are the aliphatic. Examples of aliphatic alcohol. Now come to the aromatic. Aryl, A-R-Y-L, aryl, phenyl. With that phenyl group, if one OH is attached, means benzene ring is there, one hydrogen gone, and in its place OH came, one OH. Then this is called monohydric alcohol. Monohydric alcohol, only one OH is there. Like that way, suppose 2H is replaced by 2 OH. Then this is example of dihydric. And like that way, if 3 hydrogen is replaced by 3 OH, then it is called trihydric. Then monohydric, dihydric, trihydric. Then monohydric is called phenol. All 3 are phenol. Okay, phenol. Okay, but now monophenol, diphenol, triphenol. 3 phenol OH group is attached. Monohydric alcohols may further classified according to the hybridization of the carbon atom to which the hydroxyl group is attached. Correct? Now come to the monohydric. that also can be further classified according to the hybridization of carbon atom to which the hydroxyl group is attached. Then here here maybe carbon may be sp3 hybridized, it may be sp2 hybridized. Okay, it may be sp also, but now sp3 hybridized, that example I am telling you, where this sp3 hybridization is there, carbon. Then now we have seen methyl group, that carbon, there is a sp3 hybridization, the one OH is there. Then that is the monohydric. Okay, that is a monohydric. That carbon contains a sp3 OH bond. Carbon sp3 OH bond. In this class of alcohol, the OH group is attached to an sp3 hybridized carbon. sp3 hybridized carbon atom of an alkyl group. They are further classified as primary, secondary and tertiary alcohol. This is important, just to listen carefully. Primary, secondary and tertiary alcohol means mono I am talking about. Monohydric alcohol is further divided. That now I told you sp3, carbon having sp3 hybridization, OH, that is also divided. Then first is the primary alcohol, secondary alcohol, tertiary alcohol, means 1 degree, 2 degree, 3 degree. Already I have discussed, now I am again briefing you. Primary alcohol means carbon to which OH is attached, that is attached with only one carbon. If it is attached with only one carbon, then that is called primary. If it is attached with two carbon, then it is called secondary. If it is attached with 3 carbon, it is called tertiary. And in all three, only one OH group is there. Then primary alcohol means CH2OH, and one valence is open for group like methyl, ethyl. Okay, then this is example of primary alcohol, CH2OH. Now that one valence is remaining, that can attach with either ethyl, methyl, propyl, anything. Now secondary CHOH. Now two valences joined with 2 carbon or will join with 2 carbon. It is open for joining with 2 alkyl group. Then CHOH and 2 valences opened. Then this is example of secondary. Like that way, if this COH, now 3 valences opened for, 3 valences now opened for, you can say, alkyl groups. 3 alkyl groups can join. Alkyl groups means what? Maybe methyl, 3 methyl group may join, 3 alkyl group may join, correct? 3 propyl group may join, 1 alkyl and 1 ethyl, 1 propyl, like that way can join. But all will join with the carbon, correct? They will join with the carbon only. That's why if it is joining with 1 carbon, it is a primary alcohol. If it is joining with 2 carbon, means carbon to which OH is there attached, if that carbon is joining with 1 carbon, then it is primary. If that carbon is joining with 2 carbon, it is secondary. If that carbon is joining with 3 carbon, then it is tertiary. And on all this, only one OH group is attached. Now come to the, you can say, allylic alcohol. Allylic means double bond. Here double bond, carbon-carbon double bond will be there. Then that is a sp2 hybridization. Double bond means what? See, if single bond is there everywhere, all single bond, then that will be sp3 because 4 orbitals are there, total 4. But in double bond, one is sigma bond, one is what? This carbon-carbon double bond is there. Then one is sigma bond, other is pi bond. Then pi bond is there, it means only one orbital has not taken part in hybridization, means it is sp2 only. Then now carbon-carbon double bond is there. If carbon may be long, but at least one double bond should be there between carbon and carbon. Then that will be, and OH, if OH is attached with carbon, then it is called allylic alcohol. Example, primary alcohol. Now chain is long. Suppose this was there, three carbon is there. Then first and second carbon double bond is there. First and second carbon is double bond is there. Then obviously second carbon with second carbon only one H will be there, because 2 bond and 1 bond is with H, 3 bond, and 4th bond is attached with next carbon, and next carbon is having 2 hydrogen CH2, and 1 OH is attached with this carbon. Then here again 4 valence is over. CH2 means 2 bond is over, 2 orbital is now finished, made the bond, and now 2 orbitals are remaining. The one is with OH and other orbital is with CH, neighboring CH. Correct? Then here now you see in third carbon also 4 valence is over. 2 is due to 2 in making the bond, 2H bond, H and H, and 3 and 4th, then third one is with OH, and 4th one which neighboring carbon, means with second carbon. Then this is called primary alcohol, because OH is attached with the carbon and that carbon is attached with only one carbon. That's why it is a primary. Total carbon is 3. Then OH is attached with first carbon. This is the example of primary allylic alcohol. Like that way, now it is attached with this double bond is there. Total three carbons are there. Now first carbon where it was 2 hydrogen was there, now 1 hydrogen replaced with 1 methyl group. Then now that carbon is attached with 2 carbon, one with a long chain, that is a propane chain, and other is the branch. Then now this also, this carbon is attached with now 2 carbons. Okay, one in the form of branch, other is the neighboring carbon of the long chain or primary chain. And this is the, actually it is attached with 2 carbon. Then it's example of secondary alcohol. OH group is attached with the carbon, only one OH is there. Then here this you have seen that in this also carbon number between the 2 carbon double bond is there. This is also allylic. Okay, but it is a secondary. Same way allylic is there, third example, but here now 2 branch is there. First carbon is attached with a total 3. Okay, 2 as a branch and 1 as a primary or long chain. Correct? With that, and that carbon is attached with 3 carbon and OH is already attached. Then this is the example of tertiary allylic alcohol. Then in all 3 example, in that all 3 all three, that carbon is hybridized, sp2 hybridized. Okay. Now this where OH is attached, that carbon is sp3. Here you should understand where OH is attached, as for example primary CH2OH, then that carbon is actually sp3 in all three, primary, secondary, tertiary, that is sp3. But where double bond is there, that is sp2, that carbon is sp2, you remember. Then one sp2 and one sp3, both type of hybridization is here in allylic alcohol. CH2 means what? sp2 hybridization. Okay, and CH2OH is attached, that is the sp3. Then this I told about the allylic alcohol. Now come to this aromatic ring. On aromatic ring, that is the benzylic alcohol. Benzylic, the word benzylic means with benzene one CH2 is attached. With that CH2, OH is attached. Sometimes Cl, then it will be called benzylic chloride. If Cl is attached, then benzylic chloride, CH2 must be there. CH2 must be there. With that CH2, if Cl is attached, then benzylic. And now in present case, OH is attached. Then it is called benzylic alcohol. Then benzylic alcohols, here you can see, in these alcohols, the OH group is attached to a sp3 hybridized carbon next to aromatic ring. Because it is you are not talking about the benzene carbon. Benzene carbon is sp2. Benzene carbon, because alternate double and single bond is there, that carbon is sp2. But here from this benzene, CH2 OH is attached. Then I am talking about CH2, that carbon. From this carbon, OH group is attached. Then this carbon is also sp3 hybridized, because total 4 valency is there. CH2, one is with OH and fourth one is with benzene ring. Then this is actually sp3 hybridized carbon. sp3 hybridized carbon atom next to an aromatic ring. Then here also you can tell primary, secondary and tertiary. Why you can tell primary, secondary and tertiary in this case? Because CH2OH is there. Then here 2H is there. Both H can be replaced with other you can say these things, alkyl group. Alkyl group can be replaced. Correct? Maybe sometimes phenyl group also. But now a present case, what I am telling, only monohydric alcohol I am focusing, monohydric. Then now CH2OH, only one OH is there. But now it is also possibilities that now another OH, another OH also can attach. But I will tell you that another time, because now I am telling you about only monohydric. Already I have given example for dihydric and trihydric. Means phenol. But here you think only for this primary, secondary, tertiary. Then already I have told you CH2OH. Now this C2H is there. Then both H can be replaced one by one. Suppose now CH2OH was there. Now one H is replaced by one alkyl group. One alkyl group. Then now that carbon is attached with 2 carbon. Suppose methyl, one hydrogen gone, in its place a methyl group came, suppose. Then now it is what? Secondary. CH2O is a primary because it is attached with carbon of the benzene, that is a primary. Now with CH2, 2H was there, one is replaced with one methyl group. Then now it is attached with 2 carbon. Then this is the example of secondary. Now suppose second hydrogen what was there, that also replaced by 1 mole methyl group or alkyl group. Then now the carbon to which OH is attached is now it is attached with 3 carbon. One with a benzene carbon of benzene ring, and other 2 are alkyl, and only one OH is there in all 3 cases. And this is the tertiary monohydric alcohol. Tertiary. Okay. Then these 3 are the benzylic alcohol: primary, secondary, and tertiary. Okay. Primary benzylic alcohol, secondary benzylic alcohol, tertiary benzylic alcohol. Okay. Now another concept I am telling you further: compounds containing sp2OH bond. sp carbon means carbon is attached with sp2 carbon. What I told now, all where OH was attached with the carbon which were having sp3. Correct? Despite allylic, one double bond was there. Despite that, OH was attached with the carbon having sp3 in all examples what I discussed. Now I am telling you OH will attach to the carbon which are sp2 hybridized. Then compounds containing sp2OH bond. Okay, that I am telling you now. These alcohols contains OH group bonded to a carbon-carbon double bond, that is to an vinylic carbon or to an aryl carbon, either vinylic carbon or aryl carbon. These alcohols are also known as vinylic alcohol. Vinylic. Okay. Example means that OH will be attached directly to the carbon which are sp2. Then it means that carbon and nearby carbon, adjacent carbon will be double bond. In other allylic you have seen that double bond was there, carbon-carbon double bond was there, but it was far from OH group. That carbon was having only single bond to which OH attached in allylic. Correct? But with other 2 carbon it was having double bond. Means double bond was far from the carbon to which OH group was attached. That double bond was far. Okay. OH was attached only to the carbon having sp3, hybridized carbon. But here directly OH will attach to the carbon having sp2. That is important. Means near the double bond only. Carbons, so 2 carbons are required to make the double bond. Then any carbon, it will attach. And both carbons are sp2, hybridized. This is the difference. Then example of vinylic alcohol, I am telling you. CH2CH. Suppose it was ethylene group, not ethylene. CH2CH2. Correct? CH2CH2. In the middle double bond. Ethylene, what you can tell? Ethylene. Not ethane, ethylene. And now suppose one H is replaced by OH, then that carbon will have only one H remaining. Then how it will become? CH2, CHOH, CHOH. Then this is the example of vinylic alcohol. Vinylic alcohol, CH2 double bond CH, and only with this C OH group is attached. Correct? Then this is example of vinylic alcohol. Correct? Then example of vinylic alcohol is now CH2 double bond CH and one OH. Okay, OH is attached with this first carbon. One hydrogen and one OH is attached, and after that it is attached with double two carbon with another carbon. Now come to the, you can say, phenols. In phenol what will happen? OH group will directly attach to the carbon which have double bond. You know that in a benzene ring alternate double and single bond is there. Then it will attach with the any carbon, if will attached any carbon, then all carbons are can say near that carbon double bond is there, alternate double and single bond is there. Then where double bond starts, from that carbon OH will join, attach, because that carbon where double bond is starting, that is sp2 hybridized. sp2 double bond means sp2, and triple bond means sp. Triple bond means sp because only two orbitals are taking part in hybridization. That's why sp. But in here I am talking about sp2. Correct? Then phenol is the best example. Now another example also I am telling you, that toluene, you know, toluene. Suppose in benzene one toluene is one methyl group is attached and one OH group is also attached. Okay. Then also you can tell ortho you can say methyl alcohol, a phenol. Okay, methyl phenol. Methyl will be at ortho position. Ortho you can say phenol also you can tell. Ortho methyl phenol. Okay. Then this I have discussed about the reactions alcohols. Now I will introduce ether also. Okay, ether also. I told about the this alcohol. Alcohol, phenol I have told you. Now these are the phenol only. These two example phenol C6H5OH. That is phenol, and this is also phenol. Orthomethyl phenol. Okay, methyl phenol also you can tell. OH group is there. Now ethers. What is actually ethers? Already I told you. Now again little more I want to tell you. Ethers are classified as simple or symmetrical. Simple or symmetrical. Okay. If the alkyl or aryl groups attached to the oxygen atoms, you know that oxygen has two valency, and only from each valency both alkyl may also come. Both alkyl group can attach from both valency. Oxygen will be in the middle, one left side, other right side. Or both phenyl group also can attach, or one ethyl, one phenyl group also can attach. Whatever be, that is the O is the ether group. O having two valency, one left, one right, like that. That is a ether valency, ether group. That is called ether group. Then ethers are called as simple or symmetrical if the alkyl or aryl groups attached to the oxygen atom are the same. If both groups are same, and it will be called simple. What is the condition? If the alkyl or aryl groups attached to the oxygen atoms are the same, then it is called simple. Maybe both side ethyl ethyl, both side methyl methyl, correct? Then this is a simple, or both side maybe you can say this phenyl group, same group, then this is called simple. And if it is a mixed, one is alkyl, other is propyl, one is alkyl, other is phenyl, then it is called mixed. Or also one side ethyl, one side methyl, other side ethyl, not the same. If it is not the same, one side methyl, other side ethyl, then it is called mixed. It is called mixed alcohol. Okay, when both side groups are not the same, then it is called mixed or unsymmetrical. If the two groups are different, okay, example I am telling you, if the two groups are different, okay, diethyl ether is first example I will tell you, the diethyl ether is a symmetrical diethyl ether, because C2H5O against C2H5 both are same group is attached. This is the example of symmetrical ether, okay, diethyl ether. And if one side ethyl group, other is methyl group, then this is the unsymmetrical. This is called ethyl methyl ether, and like that way, one side ethyl group, other side phenyl group, then it is again example of unsymmetrical ethers. Unsymmetrical means you can say ethyl phenyl ether. Then now I am stopping only here today. Next class I will continue. Okay, thank you.